Welcome to the session on connecting devices. We assume that you have understood the prerequisite topics, namely types of computer networks, network topology. This will help you in better understanding of this topic. To share the data between computers in networks, connecting devices play an important role. Connecting devices are key components for connecting different types of networks. In this session, we will discuss connecting devices, namely repeater, bridge, router, and gateway. Let us consider a few real-life examples analogous to connecting devices. Electrical signals are amplified for boosting the signal strength. For example, antenna in a radio receives weak signals, which are strengthened by the amplifier before converting it to sound. The amplifier can be considered as analogous to the concept of repeater in the context of connecting devices. Bridges are used for interconnecting places, for example, to cross a river and to get to the other side. This can be considered as analogous to the concept of bridges in the context of connecting devices. Traffic signals are used to direct the traffic and provide smooth flow for the movement of vehicles. Traffic signals can be considered as analogous to the concept of routers in the context of connecting devices. Port of entry is a place where a traveler is allowed to enter a country, enabling him to travel to other cities of the country. Port of entry can be considered as analogous to gateways in the context of connecting devices. Let us look at the different types of connecting devices. The connecting devices can be categorized into two types, namely networking devices and internetworking devices. Networking devices are repeater, bridge. Internetworking devices are router, gateway. First, let us look at the concept of repeaters in a network. A repeater connects two segments of a network cable. A repeater amplifies signals. This enables signals to travel longer distance without suffering from the effects of attenuation. Repeaters are useful in large networks where multiple cables can be connected together. For example, you have a thin Ethernet network with a cable segment longer than the prescribed maximum of 185 meters. You can install a repeater at some point in the segment to strengthen the signal and extend the maximum segment length. We now know that the function of the repeater is to recreate the signal from the weak signal. The diagram depicts the function of a repeater. When the signal passes through a long distance, after passing through the repeater, the resulting signal is distortion-free, and the signal is restored to its original form. Now let us move on to bridges. A bridge is basically a store and forward device that accepts frames and passes them to the next layer. It connects two homogeneous networks like two LANs, etc. A bridge divides a large network into smaller segments. For example, when an organization is spread across large distance and maybe over different buildings, then it is cheaper to have separate LANs in each building and connect them with bridges. Bridges filter network traffic. For example, if one part of a network is consuming most of the bandwidth and other parts are starving, then we can use a bridge to segregate that segment of network. Let us look at the relevance of bridge in the context of networking two LANs. If we want to send data packet from node X to node Y, it can be directly sent without the intervention of bridges. Now consider another network scenario in which we want to send the packet from node A to node G. It has to be routed through the bridge in between these networks. The packets will be first forwarded from node A to bridge. Bridge forwards the same packet to the destination G. Now let us look at routers. A router is used to route data packets between two networks. A table is used for making decision about the route. This is called as routing table. A router can connect LANs and WANs using routing table. The routers can redirect the information to take less congested routes. If the routing table does not indicate the proper address of a packet, the packet is discarded. Routers do not send broadcast packets or corrupted packets. Pause and take a look at the diagram that depicts how routers are used for interconnecting different types of networks. Let us move on to gateways. A gateway connects two or more entirely different networks working with entirely different protocols, topologies, devices, etc. Many networks exist often with different communication protocols. People working on one network want to communicate with people working on another network. This requires connecting different networks and incompatible networks at times. A gateway can translate information between different network data formats or network architectures. It can translate TCP/IP to AppleTalk. Hence, computers supporting TCP/IP can communicate with Apple brand computers. Let us look at a diagram that highlights the features of a gateway. The diagram shows how a gateway is used to connect two completely different network architecture like Novel NetWare and SNA IBM. The diagram also shows how other networks are connected using different connecting devices. In this session, we learned the different connecting devices. We can use repeaters to increase the strength of signals within a network. Repeater is a connecting device within a network. Using bridges, we can connect two networks that are homogeneous. It is also used to break the larger network into smaller segments. Router is an interconnecting device that can connect two different networks through the most optimal route using a routing table. Gateways are devices using which we can connect two dissimilar networks that use different communication protocols. For lab assignments, refer to the exercises provided under the Connecting Devices section of the lab guide. This will help you to better understand the topic.